A phrase that I've used on this channel and that keeps cropping up is mechanical sympathy. In fact, I've used it over 500 times in the videos that I've produced. What exactly is mechanical sympathy? Why should we have mechanical sympathy? What effect does that have on our car's longevity and reliability? This is the video that's just going to dissect this term so that we can fully understand what it means. When I was younger, I was always being told to use the right tool for the job. For example, if I was undoing a screw and I used a knife, the kitchen knife would nearly always come off worse. And my mum wasn't too happy with me for always bending the end of the knife. It kind of worked, I still got the screw undone, but if I had that little bit of mechanical sympathy and I understood what was involved, I would have used the right tool for the job. It would have happened much more easily and smoothly, and I wouldn't have wrecked all of my mum's cutlery. In the case of our car, mechanical sympathy is a matter of understanding fully how all of the parts work together, all of the components, the mechanics of the car. Cars are relatively complex. Pretty much everything we do in our car, every time we press a pedal, every time we turn the wheel, every time we change gear, there's an element of stress that happens somewhere else in the car. And just understanding what that is can help us to mitigate problems further down the line. In fact, the RAC did a survey and they found that drivers who had mechanical sympathy and people that drove the car steadily and smoothly had 30% fewer breakdowns. That's what we're aiming at, really, keeping our car in good condition. The biggest thing with our cars is sudden changes of speed, hard braking, hard acceleration, changes of direction, very rapid turns of the wheel. These all exert massive amounts of force and stress on the components that are involved in transmitting that motion to the road and controlling the car's momentum. It makes a big difference if we are steady and progressive with all of our actions, rather than just the binary on and off or left and right. If we feed through and we give the mechanical parts of the car a chance to bed in, to grip, to get torque to the correct level, to gain traction and be able to transmit our actions inside the car to smooth mechanical movements throughout the various components in the car. Some of the best racing drivers that we see through history weren't particularly aggressive in their driving style. In fact, most of them were very smooth, very progressive. They had this mechanical sympathy, and as a result their tyres would last longer, they could do more laps than other cars, their fuel would go further and they'd have to make less pit stops, and this all gave them a significant advantage. Plus the car wasn't breaking down on them like in the case of some of the more aggressive drivers among them. Thinking about the right tool for the job, we're on a hill, we're driving a manual car, we can either put the handbrake on, use the foot brake, or we can just hold the clutch at biting point. All of those appear to do the same thing. They keep the car arrested so it doesn't roll backwards down the hill. Now, in the case of riding the clutch, if we understand how the clutch works, the friction surfaces, we know those friction surfaces are taking a massive beating when we do that, and it really isn't worth doing. In terms of using the foot brake or the handbrake, it probably depends on whether we're going to be pulling away rather quickly afterwards or whether it's a long-term stop. But the handbrake arrests the back wheels of the car, which is where the weight is. So the handbrake will actually be more effective at arresting the car's momentum down the hill than maybe using the brake at the front. But there's not a lot in it between those two choices. It's probably safer to use the handbrake. Your foot can slip off the brake pedal, and I have known that to happen and cause accidents. When we use a manual gearbox, particularly, understanding how the gear system works and the fact that the gear speeds need to be matched before the next gear is engaged will go a dramatic long way to reducing the wear and tear on our gearbox and the transmission, and that's quite an expensive repair. If we get into the habit of rev matching, our driving will be smoother and the gearbox and all the other components in the car will last much longer just through that one little change. That's the mark of a good driver as opposed to an amateur driver or someone who doesn't have mechanical sympathy. Braking late or harsh braking can actually lead to problems within the brake system. Excess heat is generated that can lead to glazing of the brake discs, reducing the friction. The pads can start to fail over time due to the heat cycles that they're going through, this rapid cooling and heating. Whereas If we were more gentle with our braking, this heat transition would be smoother. There would be less stress on the components in the braking system, and everything will last much longer for us. It's also significantly safer. To get the very fastest lap time, sometimes we have to feed the steering, get the balance of the car into the corner, and that will maintain grip and traction. Sudden movements of the steering breaks that grip and traction, and we can actually lose control of the car or lose significant chunks of speed. I know so many people that just get in a car and drive it. They just feel that the car is made now to take abuse from the driver, that the manufacturer has taken into account all of people's habits, and it really doesn't matter what they do. And if the car breaks down on them, they blow up the engine, the transmission goes, that's down to the manufacturer. It's not their problem. Whereas in reality, the way we drive the car can really be detrimental to the lifespan of the components that are involved. Just little things like allowing the engine to warm up a little before we start driving it hard, and allowing it to cool down after we've had a bit of a spirited drive, will go a long way to smoothing out those sudden heat transitions, to allow the metal components in the car to expand and contract more smoothly, more progressively, in a more controlled manner, and gives our oil a chance to do its proper job of lubricating the engine and protecting the components within the engine. And it also minimizes problems that we might have with fuel dilution. We've spoken to that in so many other videos, and it'll also minimize the risk of fuel dilution that happens particularly when an engine is cold, where fuel escapes into the engine oil. It really does matter. I would urge everyone to get out and read the driver's manual or the handbook that came with the car. Let me know in the comments if you've already done this, or whether you just go to the manual if there's a problem or something you don't understand. Men traditionally, especially, have this attitude of being able to work stuff out. They don't like getting advice from other people. They don't like reading instruction manuals. It seems to go against the grain to do that, and they can actually cause a heap of problems. I've had so many discussions with people where a car has failed and the handbook or the manual gave very specific instructions on what to do or what not to do, and they didn't read it. They haven't been doing that, and that's resulted in a failure that was completely avoidable had they taken the time to go back to the manufacturer's instructions. If you found this video useful, please boot the like button. That really does help us get out there. If you're not subscribed to the channel, please do so. Again, that helps us with the algorithm. And I've lined up this video and this playlist that you should find really interesting. Thanks for watching. See you in these next videos.